Hi everyone. We continue in this video with Chapter 5, Trigonometric Functions and Equations. Specifically, Section 5.2, the unit circle and trigonometric functions. So here we have a unit circle, and there's a couple of things to notice. Let's suppose that we have an angle, and let's call that angle here T. So notice that we can define sine and cosine for this angle in terms of a right triangle that we could draw here, right? So, because it's a unit circle, we know that the hypotenuse is always going to be 1. And then we know that this distance here is whatever x is, and we know that this distance here for this other leg is the value of y. So notice that we can say that sine of t is equal to opposite y divided by the hypotenuse, which is 1. In other words, y gives us the value for the sine of t. Likewise with cosine, cosine of t is going to be adjacent x over the hypotenuse 1, which is just going to be x. So in the unit circle, cosine of t is equal to the x coordinate. And then tangent of t is going to equal opposite over adjacent, or y over x. So another thing to notice is that the positive or negative sign for cosine or tangent or sine depends on the quadrant where the angle is located. So, for example, if it's in the first quadrant, we know that sine is positive, cosine is positive, and tangent therefore will be positive, since tangent is sine over cosine, or y over x. In the second quadrant, we're going to have that sine is positive, cosine is negative, therefore tangent is negative. In the third quadrant, we have negative for sine, negative for cosine, therefore positive for tangent. And finally, for the fourth quadrant, we have negative sine, positive cosine, and therefore negative tangent. So next, let's take a look at example 5.6. And it says, evaluate the 6 trigonometric functions for each value of t. So for this, let's use the unit circle. So for a, t equals 0. So that means that the angle is 0 degrees or 0 radians. So that means it would be here, right? Right there. And we said that in the unit circle, sine of 0 is just going to be the y coordinate. So what's the y coordinate here? Well, 0, right? So sine of 0 is 0. Then we have that cosine of 0 is going to be 1. And we have the tangent of 0 is going to be sine over cosine, so 0 over 1, which is going to be 0. Now, how about the reciprocals? The reciprocal of sine is cosecant. So cosecant of 0 is going to be 1 over 0, and this is undefined. The reciprocal of cosine is secant. So secant of 0 is going to be 1 over 1, and this is equal to 1. And then we have that the reciprocal of tangent is cotangent. So cotangent of 0 is going to be 1 over 0, and this is undefined. For B, it says t equals pi halves. So pi halves, or 90 degrees, would be here. So it would be this angle, from here to there. So notice that in this case, sine of pi halves is going to be 1. Cosine of pi halves is going to be 0. Tangent of pi halves is going to equal 1 over 0, therefore undefined. Then we would have the reciprocals, right? So cosecant of pi halves is going to be 1 over 1, or just 1. Then we have that secant of pi halves is going to be 1 over 0, therefore undefined. And then finally, cotangent of pi halves is going to be 0 over 1, therefore 0. So for C, they want us to find the trigonometric functions for t equals pi. So that would be over here. Pi is 180 degrees, so that means all of this. Now, again, here we would say that sine of pi is going to be the y-coordinate, so 0. Cosine of pi is going to be -1, and then tangent of pi is 0 divided by -1, which is just 0. So the reciprocals, we have that cosecant of pi is equal to 1 over 0, therefore undefined. Then we have that secant of pi is going to be 1 over -1, so -1. And we have that cotangent of pi is going to be 1 over 0, which is undefined. For D, the value is t equals 3 pi halves. So 3 pi halves is all the way here, 270 degrees. So that means that sine of 3 pi halves is going to be -1. Cosine of 3 pi halves is going to equal 0. Tangent of 3 pi halves is going to be undefined. Then the reciprocals, cosecant of 3 pi halves is going to be -1. Secant of 3 pi halves is going to be 1 over 0, so undefined. We should not use the equal sign there. So undefined. And we would have that the cotangent of 3 pi halves is going to be 0. Now, why 0? Because if tangent is undefined, that means that we would have -1 over 0, right? Sine over cosine. So the opposite of this, or the reciprocal, I should say, is going to be 0 over -1, which is going to be 0. Also, one last thing, notice that letter E is going to be the same as A because they are coterminal angles, since 2 pi is 1 revolution around the whole circle. So we would end up at the same point. In the next slide, you're going to find a couple of interesting things. Now notice that first of all, it says that sine of t is equal to the sine of t plus k times 2 pi, for k belonging to the integers. And the same thing for cosine. Cosine of t is equal to cosine of t plus k times 2 pi for k belonging to the integers. Now, what does this mean? What it means is that sine and cosine are periodic. In other words, every 2 pi or every multiple of 2 pi, their values repeat. And then for tangent, we have that the values repeat every 180 degrees or every pi. So k times pi for the case of tangent. So now let's take a look at the domains of the 6 trigonometric functions. First of all, the domain for sine of t and cosine of t is all real numbers. But for tangent of t and secant of t, the domain is all real numbers except pi halves plus the multiples of pi. So why is that? Well, notice that tangent of t is equal to sine of t over cosine of t. And also, we know that secant of t is the reciprocal of cosine. So this is going to be 1 over cosine of t. So this is going to be undefined in both cases every time cosine of t is equal to 0. So where does cosine equal 0? Well, it equals 0. Remember that cosine of t is equal to 0 for t equal pi halves, 3 pi halves, and so forth. And it keeps repeating in a cyclical way. And notice that these values have a difference of pi. So the next one would be this plus pi, so 5 pi halves, and so forth. In the case of cotangent and cosecant, We also have a limitation for the domain because it says all real numbers except multiples of k times pi. Why is that? Well, cotangent of t is equal to cosine of t over sine of t. And we have that cosecant of t is going to be 1 over sine of t. So both of these functions will become undefined, where sine of t is equal to 0. And sine of t is equal to 0, where t is equal to 0 degrees, or pi, or 2 pi, or 3 pi, etc. So in the next slide, you're going to find evaluating trigonometric functions. So before we go to these unit circles, let's remember something. Now, if we have a triangle, a right triangle, with two acute angles that are the same, in other words, 45 degrees, or in radians, pi over 4 and pi over 4. Remember that there's a ratio for the sides and the legs and the hypotenuse. We know that this side is 1, this side is 1, and this one is square root of 2. So from here we know that sine of pi fourths is equal to 1 over square root of 2, which is the same as square root of 2 over 2. And then we know that cosine of pi fourths is going to be the same, square root of 2 over 2. So if we go to this figure, figure 6.14, where it talks about arc lengths that are multiples of pi fourths, these would divide the unit circle into 8 equally spaced points. But also what's interesting is that if you look at these coordinates, notice that the coordinate here is the same as the sine and cosine of pi fourths, or 45 degrees. And then for 3 pi fourths, we would have the same values, but it would be negative for cosine, since the x-coordinates are negative in the second quadrant. Then for 5 pi fourths, both values would be negative, and for 7 pi fourths, we would have that cosine is positive, the x-coordinate would be positive here, and the y-coordinate would be negative. But they are all square root of 2 over 2, whether they are positive or negative. We also have another special right triangle, which is the 30-60. So notice that if we draw a right angled triangle, and we say that this angle here is pi over 6, or 30 degrees, and this is pi thirds, or 60 degrees, we would also have fixed ratios for the sides. So this would be 1, this would be 2, and this would be square root of 3. So notice that we can say that sine of pi over 6 is equal to 1/2. Cosine of pi over 6 is equal to square root of 3 over 2. Then for pi thirds, we can say that sine of pi thirds is equal to square root of 3 over 2, and cosine of pi thirds is equal to 1/2. So if you look at figure 6.15, it talks about arc lengths that are multiples of pi over 6, and that they divide the unit circle into 12 equally spaced points. But also what is interesting is to notice the x and y coordinates here. So notice that we said that for pi sixths, cosine is square root of 3 over 2, which is the x coordinate, whereas sine is 1/2. For pi thirds, or 60 degrees, we said cosine is 1/2, which is the x coordinate, and sine is square root of 3 over 2. But then for the other multiples, except of course for the ones that lay on the x and y axis, but for the other multiples we have again the same numbers, right? 1/2 square root of 3 over 2, and what changes is the signs depending on whether x is negative or y is negative, or they're both positive, or one is positive and the other one is negative. So that depends merely on the quadrant. So notice that in the second quadrant, where cosine is negative, notice that basically we have the same as here, but with negative 1/2 for the cosine of 2 pi thirds. And likewise, notice that 5 pi over 6 is very similar to pi over 6, but now the cosine is negative.